Hi, let us look at this question. So here we are asked, so how many number of subsets of 1, 2, 3 till n minus 2 are there that do not contain any pair of consecutive numbers, right? So what is a subset? So basically if there is a set 1, 2, 3, so its subset can be a 5 set. So only this single number containing sets, also called the singleton sets, or this can be like 1, 2 and 1 3, or this can be 2 3, or it can be the whole set of 1 2 3, right? So like what we are asked in the question, so these are all the subsets of this 1 2 3, right? So we are asked to find some specific subsets that do not contain any pair of consecutive numbers. So like this contains a pair of consecutive numbers, and this also contains a pair of consecutive numbers, and this also contains a pair of consecutive numbers. So these three are not what the question is asking for. Instead it's asking the other ones. So here, as there is only one number, so these are not, so this cannot contain any pair of consecutive numbers, right? So these are 5 1 2 and 3, and similarly 1 3 is another, because 1 and 3 are not consecutive, right? So here there will be like 1 2 3 4 5, so 5 number of sets are there that are the subsets of this 1 2 3 and do not contain any consecutive numbers, right? So let's see how we can generalize this and what pattern it's like forming. Okay, so so for one, you can see like there are two sets, so it's basically the empty set 5 and this set 1. For 1 and 2 it can have like 5 1 and 2, right? For 1 2 3, you can see I've got already this like 1 2 3 4 5 numbers. So here it is 2, here it's the number is 3, here the number is 5. So if like you have 1 2 3 4, so like by brute force, like finding all the numbers and then doing a very tremendous job of writing down all the possibilities, so you can see you will get 8 such subsets that are part of this non-consecutive subsets. Okay, so you can see it's already forming a pattern, like so 2 is there, 3 is there, 5 is there, 8 is there. So automatically the term we are looking is some of the previous two terms, like and this 3 plus 5 is 8 and so on, right? So we have a solution in mind, that the what term we are actually looking for is basically can be found using the sum of these last two actually previous terms, right? So an is basically an minus 1 plus an minus 2. So this should be our intention when we try to analyze this for such small sample cases, right? So let's see if this intuition is true in general and how this problem is unfolding. Okay, so what you can do in this problem is that, so I'm coming, so why this is they're giving the n minus 2, I'm like explaining in a bit. So now let's take, suppose there are n, like n elements are there. So what you can do is that, so suppose these elements are 1 2 3, basically it goes up to n, right? So like you can divide it into two disjoint cases. So one will be the one where the element, so a particular element, let's say 1 we take, so 1 is not contained in such consecutive sequence. So like it has a large number of subsets. So specifically it has such subsets that are not consecutive, and we are dividing these parts, so the non-consecutive integer containing subset, into two parts, one that contains one and one that do not contain one, right? So if suppose it contains, so it do not contain one, so it's basically, so there are, we are trying to find all these subsets that are going from 2 to n, right? So basically it's not different from finding the subsets that are there in like 1 3 or n. Okay, so like n minus 1, sorry. So what I'm telling is that, so basically if 1 is not there in this subset, basically it starts with 2. So mathematically is it has no difference than being a like a group of n minus 1 consecutive integers. So from here, so here we have a consecutive integer from 1 to n minus 1, and here we have the same like same pattern of consecutive integers to n. So fundamentally these two sets are similar, right? So these two have, we should have an equal number of like like non consecutive subsets, right? So another way we can explain is like that. So if we like particularly take this n out, so like we are, so this is basically an, that is the number of sub non-consecutive integer having subsets from 1 to n. So what we are doing is that, so we can like do it in a similar way also. So like we can eliminate this, like consider two cases, one that contains n and one that doesn't contain n. So if you take that subset that does not contain n, so automatically it will go from 1 to n minus 1. So in any way we do we'll see that this, like if you like eliminate one or disconsider a particular element, so you will be left with n minus element. But like you cannot disconsider like from the middle. So if you like take this middle one out, so then these numbers will not be consecutive. So this will not be the same fundamental set as this, because here it's a continuous array of n minus 1 consecutive integers, and here also it is a continuous array of n minus 1 integers, right? So that property you should keep in mind. So either you can delete the first one or delete the last one. You should always keep this set as a set of n minus 1 consecutive integers, right? So let's come back to the original problem we are discussing. So now we have just like considered the numbers that do not contain 1 in its subset. So the numbers are like consecutive subsets from like these numbers, so 2 to n. So for the second case, what we are considering, the number that must contain 1. So it must contain 1, and maybe it will contain some other element from the rest of the numbers. But one thing you should note here is that, so if 1 is a must, then the next, so the number cannot contain 2, right? So basically you have to consider only the numbers from 3 4 till n, right? So it's like we are considering this n minus 2 consecutive numbers, right? So suppose if the number we are getting from here is, suppose the consecutive subset from here is 3 5, then 1 is getting automatically union with this, right? So 1 is getting combined and it's like becoming 1 3 5. So if we are getting a subset 3 5 from here, so that is corresponding to our answer 1 3 5, right? So the number of elements possible on this set, so the number of elements that have no two consecutive integers is same as the number of integers that always contain ones, right? So basically what we are actually doing, so you are like finding the number of subset from this and we are just unioning 1. So because 2 is not there, so we can always union 1, right? So what is this? So this is basically the number of subset that contains no consecutive numbers from a consecutive set of n minus 2. So basically what we are getting, so the number of subsets in the original problem is basically got disjointed into two mutually exhaustive cases, right? So one is the, when we are considering that the number will never contain 1, so this is coming from this subset which is an n minus 1 consecutive integer, so that is a n minus 1, plus all of these are the subset that are containing 1, right? That are always containing 1. So basically these are like a n minus 2 in number, because it is kind of similar to considering the numbers from 3 to n which are n minus 2 in numbers, right? So it is basically a n minus 2. So we are getting at this similar kind of Fibonacci relation here. So like an is a n minus 1 plus n minus 2. So this was our initial intuition which we have proved formally. So this relation is like it will always give you the Fibonacci numbers. So if like as you can see. So here for n is equal to 1, so if there is one set, so we have two such subsets. If the number is 2, then we have three such subsets. So it's like, if for this set we have got the answer 2, for this set we have got the answer as 3, and so on, right? So if the number of elements is 3, it's like the number is 5, right? So the Fibonacci sequence is like 1 1 and 2 and so on, right? So it's going so on. So here, if the number is like, so this 2 is, this is just the third Fibonacci number, right? So it is usually denoted by f3. So because this is generally f3, and for 2 this is generally f4, and for 5 this is generally f5, right? So if the number is like n, it's like f of n plus 2. That's why in the question we are asked to find from 1 to n minus 2, because it just, so as the number is n minus 2, it will give you the Fibonacci sequence of n minus 2 plus 2, that is the nth Fibonacci number. So nothing else. So just if the sets are like running from 1 to n minus 2, you will, the answer will be the nth Fibonacci number, that is f, right? So thank you.